Hi, welcome to another video of Chem with Com. Today we're going to be talking about measurements, prefixes, dimensional, and analysis. This is the second part of this series. Specifically, we're going to be, or sorry, third part of this series, we're going to be talking about dimensional analysis. These are 4 videos in this series, so let's get rolling. Okay, so again, your calculator is going to be very important for these sections. Get a non-phone calculator ASAP. Practice it with every lecture, assignment, and use the same one for the exams. And then these are some free online ones to hold you over. You're going to need a physical one for the exams. Another thing is you always want to put brackets around all exponential notation numbers when using your calculator. Eventually you don't need to, but at this point when you're learning, it's just easier to do it on everything. All right. Okay. So dimensional analysis is just converting things from one unit to another, right? And we're going to do this in 3 steps. I'm going to try to keep this as simple as possible. And again, when you're more advanced, you don't have to do every step. But for now, this is how we're going to do it. We're going to, step 1, find the conversion rate. Step 2, write it as 2 fractions. Step 3, multiply the original value by that fraction. That's it. 3 steps, you can convert anything in the world, right? So let's try this. Okay. We're going to convert $1, $1 to Mexican pesos. So step 1, find the conversion rate. It's a number, a unit, followed by an equal sign, a number, and a unit. We'll say different unit to be, right? And conversion factors are kind of exact numbers. So when we convert things, we don't calculate, we don't count the conversion factors as with significant figures, right? We use the other number that we're using, okay? Or the number that we're trying to convert. Okay, so step 2, write it as 2 fractions. So here what I did is I took I'll try and do this in color to make it, see if we can keep it there. So 1.00, I put that on the bottom here. Let's do a different color for US dollars and US dollars. This is a fraction, right? It has something with a line over something else. It's like saying that line could mean division, right? It's a fraction line, right? So this is how we're going to write it. And then let's do green for 17.29. Right, and then we're gonna do orange. I don't know if we could see orange on this. I guess it's okay. Orange here for Mexican pesos, right? Oops, I didn't finish this one up. This should say MXN on there too, right? So we're gonna have that boxed up. We're gonna have red. So we're gonna write it as 2 different fractions. We're just gonna basically put one of them on top, the other one on the bottom, and then for the other fraction, what we're gonna do is we're going to flip them across that fraction line, right? And the US dollars looks like blue. I'm gonna try to color code these things so you can see where I'm getting it from. And then I'll do what was the 17? Green, 1729. All right. So write them as 2 fractions. Then we're going to multiply the original value by the fraction. This here was the original value. Right? That was what we're trying to convert. That original value is here. We're multiplying it by the fraction. Now we have to figure out what fraction to use. What we want to do is we want to be able to cancel out the original unit. And to do that, we have to have the original unit on the bottom of the fraction. So we're going to use this fraction, right? The US dollars cancel out and it just becomes 17.29 Mexican pesos. And then since we're starting off with 3 sigfigs here, we're going to end up with 3 sigfigs at the end. So here, 3 sigfigs. Here, there are now 3 sigfigs. All right, let's do another one. We could reverse this. Now let's try and convert some not the same, not one, because sometimes one is a little confusing. Let's convert $13.50 to Mexican pesos. Step one, find the conversion rate. It's exactly what we had before because we're still converting dollars to pesos. We're going to write it as 2 fractions. And again, I left that out, but I'll correct that on the note-taking slides. Right? So here again, our original value is 13.5 US dollars. So we want the fraction that has US dollars on the bottom, which is this one. So we're going to write it as 2 fractions. We're going to pick the fraction that has the same unit on the bottom as the original value, right? Okay, so then US dollars cancel out. We're left with Mexican pesos. It ends up being 233.415 Mexican pesos. And for this, what you're doing is you're taking 13.5 US dollars, and that's like saying 13.50 US dollars over 1 multiplied by 17.25 Mexican pesos over 1.00 US dollar, right? There's no fraction line here, but it's the same as being over 1, right? So it's still on top of the fraction line at 13.5. So these will cancel out. You're left with Mexican pesos. I think they gave us 6 significant figures, but since here we have 4 sigfigs, we have to have 4 sigfigs here at the end. All right. Let's keep going. Again, dimensional analysis is converting things from one unit to another. So nothing crazy, right? We're going to convert 150 Mexican pesos to US dollars, right? So now we're going the backwards way, right? Or not the backwards way, but we're going backwards, right? From what we did the last 2 examples. So here is the same exact conversion rate, and we're going to use the same, find the conversion rate, write it as 2 fractions, right? So we're going to write this as 2 fractions here. 1, 2. But remember what we did before. We're going to use the fraction that has the same unit as the original value that's on the bottom of the fraction. So the original value is Mexican pesos. So we have to use the fraction with the Mexican pesos on the bottom here. So this is what we're going to use because we want the Mexican pesos to cancel out. And so the Mexican pesos cancel out. We end up with 150 times 1 divided by 17.29. That gives us 8.67553 US dollars. But this is 1, 2, 3, 4, 5, 6 sigfigs. Here are only 5 sigfigs, so we have to cut it off here. And then this is our answer, 8.6755 US dollars. And this is 5 sigfigs. All right, so that's our answer. All right. So again, we're going to go through these the steps just to show you, just to reiterate and reinforce what we're trying to talk about, all right? This is the book way to do it. It's very wordy, but basically what you're doing is you want to find the conversion rate, or sometimes people call it conversion factor, right? All right, all of these are going to be a number with a unit, an equal sign, a number with a different unit. So I'm going to highlight these. Um, I'm going to put the red box here, number with the unit, number with the unit, number with the unit, number with the unit, number with the unit. It doesn't always have to be one. It just happens to be one over here. Number with the unit, number with the unit, right? Equal sign. We'll box that up in green. Number with the, sorry, equal sign, 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 right? And then a number with a different unit. All right, so we have another number with a different unit. It could be the same number, it just has to have a different unit, right? Number and unit, number and unit, number and unit, number and unit, right? Number and unit. Sorry, I know I'm repetitive, but it's a simple calculation if you can make it simple. And sometimes it's hard to click, right? You do a lot of work, you practice it, still doesn't click. Once this clicks, you're done. Like you get it and you never have to relearn it again. It just clicks, right? But it takes a lot of work to get to that point where it clicks. So again, find the conversion rate or factor, right? Sometimes the second number is implied. So sometimes number is implied, right? So for instance, if I say 60 mile, if I drive 60 miles per hour, right, that's 60 miles per hour, right? But we all know when we're talking about this that that hour is one. We don't say, oh, we drove 60 miles and the rate of speed is 60 miles per 4 hours, right? There's an implied 1 hour. And let's say we get, oh, sorry, let's say 60 miles per hour. Let's say we get 25 miles per gallon, right? So we say we could drive 25 miles on gallon of gas, right? But it's not, we usually don't say we drove 25 miles on 17.3 gallons of gas, right? The miles per gallon is 25 miles per 1 gallon. Right, and density calculations. Density, let's just make something up, right? Let's say there's something had a density of 30.1 grams per cubic centimeter, right? Typically, that's going to be a 1 cubic centimeter. So these, even though they're not explicitly said, right, miles per gallon, miles per hour, grams per cubic centimeter, right? If there's no number, it typically means it's one. All right. All right. So again, find the conversion rate. Every conversion rate must have a number with a unit, an equal sign, and then a number with a different unit. That's it. Sometimes the number is implied because it's one, right? All right. Second step, write it as conversion rates. All right. So this is our, so write the conversion rate as two fractions, right? So this is our conversion rate, right? This is from the book. All right, so what we're going to do is write it as two fractions. So let's start off with by putting the 2.54 on top and the 1 inch on the bottom. Right? And it has that equal sign, so we know what's conversion rate, right? Cool. So then we do our let's say this is going to be the fraction one. This is going to be the easiest part of this, I think. If you don't know fractions that well, this might be the hardest part, right? But once you know all of this, this is going to be the easiest part. Then we just swap the top and the bottom, and now we have our two different fractions. Let's try one of these. Let's do something like this one here. Oops, I wrote over that. Let's start over. All right, so it's going to be 1 quart equals 0.94635 liters. We're good because we have our number, our unit, our equal sign, our number, and our unit, right? The unit here is liters. So let's do two fractions. Let's put the quart on top. 1 quart equal over 0.94635 liters. Or you could write it as, and we're just going to flip-flop those numbers, 0.94635 liters. On the bottom is 1 quart. So we have fraction 1 and fraction 2. So again, step 1, find the conversion rate. Step 2, write the conversion rate as two fractions. That's all we're going to do. All right, here's where all of it comes together, right? Multiply. Again, this is the book way to do it. I give you the book way because if I miss something or misspeak, I want you to be able to clear that up on your own. But I think I was able to do this pretty good without a ton of mistakes, right? But multiply the original value by the fraction. Okay. Commodore's way. Use the fraction that has the same units as the original value on the bottom of the fraction. This is the most important part. When I teach students, they're always like, well, am I supposed to divide or multiply? Well, I never divide. I always just multiply their original value by the fraction. That's all I ever do. I have a hard time. I have a pretty poor memory. So it's hard for me to memorize things and keep stuff in my head. So this is how I do it. I don't have to memorize divide or multiply, right? So again, use the fraction that has the same units as the original value on the bottom of the fraction. And the original value is the value you are trying to convert. Value you are trying to convert, right? And then the last step is you're going to cancel out any units that are the same, and then you're left with your new value, your new unit, right? All right, let's try this out. Find the conversion rate. Well, the problem is convert 3.97 nanometers to meters. Step 1, find the conversion rate. Well, we're trying to go from nanometers to meters. So we have to have a conversion from nanometers to meters, right? Let me just try and move this button out of the way. There you go. Actually, that worked out great. All right. So I see the word nano. I'm like, okay, I got to figure out what to do here. So I see nano. I know that nano now is 10 to the negative ninth. So nano is 10 to the negative ninth meters. 1 nanometer equals 10 to the negative ninth meters. Or you can look here, right? Nanograms. Sorry, they have these numbers in front, but that would work too, but it's easier to use the number 1, right? So the abbreviation, the symbol for nanometers is lowercase n, lowercase m. The symbol for meters is lowercase m, right? So we're going to write it as two fractions, 1 nanometer over 10 to the negative ninth meters, right? Or 10 to the negative ninth meters equals 1 nanometer. So I'm going to put a star here. Don't swap numbers and units, meaning 1 always has to stay with nanometer, right? 10 to the negative ninth always has to stay with meter, right? So 10 to the negative ninth has to stay with meter. 1 stays with nanometer. All right, we'll swap those. 1 nanometer. Remember, 1 always has to stay with nanometer. And 10 to the negative ninth always has to stay with meters, right? In this conversion, right? Sometimes you'll have different conversions, but you always have to, you cannot swap the numbers in units. They have to stay together. That's going to be one of the main points. All right. Multiply the original value by the fraction. Use the fraction that has the same unit as the original value on the bottom. Well, this is our original unit, or this is our original value. Nanometers are our original unit. So we have to use this fraction because nanometers is on the bottom. So we're going to bring that down here and look what happens. Nanometers cancel out and we have meters at the end. And that's what we want, right? We're converting nanometers to meters. All right, so we plug that into our calculator. Let's take a look at our calculator. Again, I know you're learning stuff, learning some math at the same time you're doing chemistry, so sometimes it's a little wonky. Let's delete this and let's try it. All right. 3.97 times 10 raised to the negative ninth, and that equals that. So you don't have to change it. It still is 3.97 times 10 to the negative ninth. All right. And we have 3 sig figs here, 3 sig figs here. So we're, sorry, 3 sig figs here. So we're all good. All right. And then we canceled out units, right? We canceled out the nanometers. Let's try it again. This is going to be now a 2-step conversion, right? First, step 1, find the conversion rate. Let's try this. Let's try to go from kilomoles to micromoles. Well, if you look on your prefix table, you're not going to see a direct conversion to micro. There are tricks around this, but this is introductory chemistry. We don't want to show you shortcuts or things you're going to get confused with, so let's try this. So what we're going to do here is, oh, sorry, kilomoles to micromoles, right? Sorry, I think I said kilometers or something like that, but 9.4 kilomoles, we know there are 10 to the third, kilo means 10 to the third, right? So 1 kilomole equals 10 to the third mole. So that'll let us convert from kilomoles to moles with no prefix. So that's going to be our first conversion. Our second conversion is going to be from moles to micromoles. That's our second conversion, right? Conversion 1 and then conversion 2. That's a big step. It might take a few practice problems to get this. So if you didn't get it right away, that's totally normal. This is one of the hardest chapters in chemistry. And people that move on to other classes after introductory chemistry, such as general chemistry or physiology or kinesiology, this is where they get tripped up is conversions. So don't get frustrated and get frustrated a little bit. Try, work, read, do the videos, right? And you'll get through it, right? Okay. So again, we do not have a direct conversion from kilo to micro, so we have to do a 2-step conversion, all right? And because we are going to go from, we know how to go from kilomoles to moles, and we know how to go from moles to micromoles, right? That means we can do a 2-step conversion and get our answer. So we're going to do the same steps. Find the conversion rates. We did conversion 1, conversion 2. Now we're going to break these apart into 2 separate fractions, 2 sets of 2 fractions. This is for, we'll see, conversion 1, and this is for conversion 2, All right. Conversion 1, conversion 2. All right, so let's do that. So again, we just doing the fractions. First, we started with kilomoles on top, 1 kilomole over 10 to the third moles. And then now we have 10 to the third moles on top, and then 1 kilomole on the bottom. Here we said 10 to the negative 6 moles on top, 1 micromole on the bottom. Then here we had 1 micromole on top, 10 to the negative 6 moles on the bottom. All right, done. Second step is always going to be the easiest step for us. Step 3, multiply the original value by the fraction. Use the fraction that has the same unit as the original value on the bottom. Cancel out any units. All right. Our original value is kilomoles, right? Kilomoles right here. Kilomoles. So we want that on the bottom. So we're going to use this one. Go here. 9.47 kilomoles times that fraction. The kilomoles cancel out. And we're left with 9.47 times 10 to the third moles. Now, this now becomes our quote unquote original value when choosing the next fraction. Choosing the next fraction. Sorry, n, next fraction. All right. So now what we're going to do, we're going to carry that over here. This is our new value. This is our, because, right, we did conversion 1, then we have a new number in unit. Now we're going to do our second conversion, but we're going to still multiply the original value, and that's going to be our kind of new original value, where we have moles on there, and then we're going to find now moles on the bottom. It actually ends up being this one, right? So we're going to bring that down, trying not to draw over everything, but now it looks kind of funky, but here. Right? Since we had moles on top now, we're going to have moles on the bottom, and they cancel out, thankfully. And you do 9.47 times 10 to the third divided by 10 to the negative 6. But look what the units we have, right? We have micromoles because micromoles did not cancel out, and it's on the top of that fraction. Let's do some math here. Let's do this one now. Clear this. We'll do that first set of math. 9.47 times, and since I suggested this, let's do this, times 10, and then we're going to press that second button. Oops, let's see here. So I guess we just hit this button to the third, and then the arrow, and then close parentheses. And it just becomes, it could be 9470, which is the same as 9.47 times 10 to the third. All right, so then let's do this second one. 9.47 times 10 to the third. So 9.47 times 10 to the third, brackets, divided by, and I'm just going to put this in brackets because I suggested it, and I'm going to keep it consistent, 10 to the negative 6th. I'll do the arrow, parentheses, and then hit enter. So I got this pretty large number, and that's going to be the same number as 9.47 times 10 to the 9th. right? So basically this number, 1, 2, 3, 4, 5, 6, 7, 8, 9. It's like 9 billion, 470 million micromoles. All right. Again, this math stuff is difficult. It gets frustrating. This is where you're going to really have to start to practice a lot, a lot, a lot to get comfortable with it. All right. Let's continue. Let's start jamming through some practice problems. All right. Step one, find the conversion rate. So we're going to convert a volume of 9.345 quarts to liters. So we find this. Says 1 liter equals that. So 1 liter equals 1.057 quarts. Next step, write it as two fractions. 1 liter on top, 1.057 quarts. Or you can put 1.057 quarts on top, 1 liter on the bottom. Step 3, write the original value you're trying to convert. And then we're going to choose the fraction that matches this unit with the units on the bottom. So we're going to use this one since quarts are on the bottom, right? Times 1 liter over 1.057 quarts. So if you look what cancels out, quarts cancel out, and we're left with liters, thankfully. So we have liters at the end. We have 9.345. Let's go back here. Clear this. 9.345 divided by 1.057 equals this number here. Let's see if we can copy that. Probably not. 8.8410. Let's see. We can just do this. 1, 2, 3, 4. Let's say 8 point. Wait, I need to change. 8.841059.6. All right. We have 4 sigfigs here. Remember, we're not using the conversion rate for sigfigs. We're going to cut this off at 4 here. So it's going to be 8.841 liters. And this has 4 significant figures. All right, let's do another one. So again, 3 steps. What is the volume in liters of 1 ounce? Given that 1 liter equals 1.0567 quarts and 1 quart equals 32 ounces. All right. So we're trying to go from 1.000 ounces to liters. But we don't have a direct conversion rate for that. So here we're going to have to skip to. This lets us go from ounces to quarts. So ounces to quarts. And then we can go from quarts to liters. All right, so it's going to be a 2-step conversion. Again, that's a big jump, right? It's hard to, for me, it's hard to figure out if it's a 2-step. So I think you might have a hard time there as well. I've had most of my students also, this is much harder than a single-step conversion. So, and it's kind of connecting the dots in your head. I can't really teach you how to do this. You have to, it's like a puzzle, right? Everyone does puzzles their own way. Typically, some people sort by color, maybe by shape, maybe some do the borders first, some start with the corners, right? But you have to get a system of how to do this. And there's some stuff that works, right? Color matching, shape matching, doing certain sections, print matching, patterns, things like that. And you're going to do the same thing for chemistry, and for dimensional analysis that you're going to have to pick up. All right, so this is step one. Is going to find the conversion rates, and they have them written out for us. One liter equals 1.10567 quarts, and 1 quart equals 32 ounces. All right, step two, write them as fractions. 1 liter, 1.0567 quarts, or 1.0567 quarts over 1 liter. And we have this one, 1 quart over 32 ounces. Or flip-flop it, 32 ounces over 1 quart. All right. Step three, what's our original value? 1.000 ounces. All right. So we have to find ounces with the original value on the bottom. And I see it with the original unit on the bottom. And that's going to be this right here. So we're going to use this one. Oops, let me just, So we're going to say 1 quart, 32 ounces. All right. So look what cancels out. Ounces cancel out. We're left with quarts. So we say 1 times 1 divided by 32. Let's try that. Go back to this calculator. 1 times 1 divided by 32. 0.03125. So I got 0.03125, and we have quarts. All right, so let's write this down here, 0.03125 quarts. Now, look here. We're going to use the second conversion rate because now quarts is on the bottom. This is our second conversion rate. 1 liter divided by 1.0567 quarts. Look what cancels out. Quarts cancels out and quart cancels out. So we're left with liters. So we know our answer is going to be in liters. So we're going to divide by 1.0567. So divided by 1.0567. And I got 0.02957. 0.02957. We'll say 0.02953. Okay, so here we have 4 sig figs. So here we need 1, 2, 3, 4 sig figs. Cut it off there. It's 0.02957 liters. And this is 4 sig figs, right? So that worked out great. All right, let's do another. Okay, this one gets a little wonky. This is a long video. All right, so let's do this. Toyota Prius hybrid uses 59.7 liters of gasoline to drive from San Francisco to Seattle, a distance of 1,300 kilometers, right? 2 significant digits. What average fuel economy in miles per gallon did the Prius get during this trip? All right, so we need to go from, they want it in miles per gallon. So we're going to go from 59.7 liters. Let's redo this. Let's put the kilometers on top because let's figure out what's going on here. So we need miles per gallon, but we're starting with, look at this, kilometers and liters. So we know that kilometers can be converted to miles, and we know that liters can be converted to gallons. So let's do that. Our first thing is 59.7 liters. Sorry, let's call this part A, I believe. Let's write that as part A. All right, 59.7 liters. We need the conversion rate for that. Conversion rate is, let's see here, 1 liter, it's right here, equals, let's see, what are we trying to do? Liters to quarts, 1 gallon, 4 quarts, right? So let's do liters to quarts equals 1.057 quarts. All right, that's step one. Step two, write it as fraction. 1 liter over 1.057 quarts. Or you could say 1.057 quarts over 1 liter. All right, step three, we're going to change 59.7 liters. We have to use this one because liters is on the bottom. So 1.057 quarts over 1 liter. Liters cancel out. 59.7 times 1.057. What is it? 59.7. 59.7 divided by 1.057. And we got 56.4806. 56.0846. And this is quarts. All right, so then we do 56.0846 quarts, but we want to go to what? Gallons, right? So we're going to skip a step here. We're going to skip the step, rewrite it as fractions, because we know what goes on the bottom, right? If we're going to use this, we can create the fraction right here in the problem. Because we know we have quarts here, we're going to need quarts on the bottom, so we put it on the bottom. Quarts cancels out, and we're left with, oh, we didn't do the math. So let's do the math. We'll say that divided by 4. Oops, let's type that in. 56.4806 divided by 4. And we got 14.12. And it looks like we need 14.12 gallons. But we're going to do an overline on the 1 because we need 3 significant figures. All right. Let's do now 1,300 kilometers to miles. I'm going to put a line here just to separate what we're doing. And we're going to say we have 1,300 kilometers. So we have to have the conversion rate. Step 1 is going to be 1 mile equals 1.60934 kilometers. Write them as fractions. Actually, let's skip this step because we're going to do it on the fly. Let me just also move this back a little bit. So this is step 1, step 2, step 3. We're going to say 1,300 kilometers. We know we're going to have to put the kilometers on the bottom. 1.60934 kilometers. And this is 1 mile, right? So we're going to cancel the kilometers, and that's going to equal 1,300 divided by 1. I have to redo that one. Let's do this calculator. We're just going back and forth to show you the different calculators. Oh, did this one break? Let's reload this, see if we can get that working. All right, let's try it. Okay, it's working again. 1300 divided by 1.6 something. 60934. 0934. Boom. 807.78. 807.78. So this is 807.78 miles, because that's the last one we have left, right? So if we do miles per gallon, it's going to be, and for sig figs, right, we only had two sig figs here. So let's put an overline here. I'm going to say 807. 807.78 miles with the overline on the zero, right? Because we're trying to do miles per gallon divided by 14.12 gallons. Overline on the one. So we have two sig figs here because of where the overline is, three sig figs here where the overline is. And so we should have two significant figures at the end. So 807.78. I'll go back to this one. 807.78 divided by 14.12. And that gives us now 57.208 miles per gallon. 57.208 miles per gallon. But we need two sig figs. We're going to cut it off here. So this should be 57 miles per gallon, right? All right. That's a long one. Let's do part B over here. It says, if gasoline cost $3.90 per gallon, what was the fuel cost for the trip? So if we're trying to find how many dollars we spent, right? This is, we drove, let's see, 807.78. I'm going to put the overline here. Times, or sorry, miles. This is our original value. We're trying to convert that to dollars, basically. What was the fuel cost, right? So our conversion rate is going to be $3.90 equals 1 gallon. We'll do old school and do all the steps. Write them as fractions. You don't have to, but again, we're just going to practice. 1 gallon over 3.90. Since we have miles here, sorry, 3 per gallon. Sorry about that. Oops. Let me go back up. So we're actually going to use gallons because we're trying to find the cost. So my bad. We're actually going to use 14.12 gallons. And we're trying to figure out the dollars, right? So we have dollars and gallons, gallons and dollars. So it's going to be 14.12 gallons, and that's going to be the line over the one, times, we have to use this one because the gallons are on the bottom, over 1 gallon. These cancel out. 14.12 times 3.9. 14.12 times 3.90. Enter. 55.068. And this is now dollars. 55.068. We have 3 digits, so we're going to cut it off there. It's going to be $55.0 for the trip. All right. That was a tough one. All right. So we're going to do a couple more here. Okay, so I know this is a long video, but we're going to do a couple more examples to get them all here. So now we're going to convert moles to something called moles to grams, right? Now, where have we heard the word grams per mole before? Well, periodic table, right? The periodic table has molar masses listed in the units of grams per mole. Grams per mole lets you convert from grams to moles and moles to grams because it's a fraction, right? It has numbers. 1, 12. So carbon, let's scratch that out, but let's take a look. We're going to go from moles or grams to moles, right? That's exactly what we're doing, grams to moles. So we're trying to convert this, specifically carbon. Well, again, when you see the word grams or moles, you're going to go directly to the periodic table. This is listed as 12.01 grams of carbon equals 1 mole of carbon. Or you can write it like this. I like this better because it's shorter. It still means the same. 12.01 grams sees the symbol for carbon equal 1 mole of carbon. So we're going to write it as the fractions. This is step 1. This is step 2. Right? And then for step 3, we're going to take the original value, 0.26 grams of carbon. We're going to multiply that by the fraction that has that on the bottom, grams of carbon on the bottom, which is this one. So we say 1 mole of carbon divided by 12.01 grams of carbon. Grams of carbon cancel out, and now we're left with moles of carbon because that's all we have left. So we're going to do 0.26. Where are we at? Let's go back to this other calculator. 0.26 divided by 12.01. And I got 0.0216486. 0.0216486. 02, I already forgot. 16486. 16486. So we have two sig figs. So I need 2 sig figs here. Cut that off there. It's going to be 0.022 moles of carbon. So same exact way, right? Find the conversion rate unit. This case, the conversion rate was actually on the periodic table. And write it as fractions. And this actually started as a fraction. So you can write it like this, but this actually started as 12.01 grams of carbon per 1 mole of carbon. But you could just flip that around and have your second fraction, right? All right, let's try another one. Let's say how many atoms of sodium in 1.3 moles of sodium? Okay, well, we know that Avogadro's number 6.022 times 10 to the 23rd anything. In this case, we could say atoms equals 1 mole. So this is step 1. And this is going to be, we wrote it down here, 6.022 times 10 to the 23rd atoms of sodium equals 1 mole of sodium. And we know that because it's 6.022 times 10 to the 23rd anything equals 1 mole of anything. Here we have atoms of sodium. That equals 1 mole of sodium. Right? So we write it as fractions. And let's do step 3 because this is step 2 here where we wrote them as fractions. Let's start here. 1.3 moles of sodium. So which one has moles of sodium on the bottom? Well, this one does. Multiply by 6.022 times 10 to the 23rd atoms of sodium over 1 mole of sodium. Moles of sodium cancel out. Atoms of sodium is going to be our answer. Let's try it out. Let's do the calculations. Go back to this one, clear this one. So it said 1.3 times, and this is exponential notation, 6.022 times 10 to the 23rd. Move that back, close parentheses. 7.8 times 10 to the 23rd. 7.8 times 10 to the 23rd atoms of sodium. All right, since we had 2 sig figs here, we need 2 sig figs here. All right, so again, 3 steps for convert anything. Find the conversion rate, write in as fractions, multiply by that fraction. All right, so we're going to also have to do temperature conversions in this class. And so here's a list of temperature conversions you could use. Fahrenheit to Celsius, Celsius to Fahrenheit. These are sort of kind of quote unquote plug and chug. We basically put your number in, do the math, and then you're done. We're going to have to remember a couple things here. PEMDAS, order of operations, right? Parentheses first. So parentheses, exponent, multiplication, division, addition, subtraction, 2 little arrows here to show that multiplication and division do at the same time, left to right. Addition, subtraction, left to right. So let's jump in here. All right, convert 80 degrees, 80.92 degrees Celsius to Kelvin. Well, let's do that one first. So we have step 1 or problem 1, 80.92 degrees Celsius to Kelvin. Well, here we go. Convert Celsius to Kelvin. We just plug in our Celsius here. So it becomes, I guess I'll just draw arrow here. Temperature in Kelvin equals our temperature in degrees Celsius plus 273.15. Well, that's going to be 80.92 degrees C plus 273.15. So 80.92, let's go back to this calculator. 80.92 plus 273.15, and that's going to be 354.07. 354.07 Kelvin. What we want is the same amount of sig figs to start to end, so we need 4 sig figs, so it's 354.1 Kelvin. All right. Second one. We're going to go from 80.92 degrees Celsius to Fahrenheit. So we're going to find Celsius to Fahrenheit. This is the one we're going to have to use PEMDAS, the order of operations. Let's check it out. All right, so we're going to use, or I'll put it here. Temperature in degrees Fahrenheit equals 9/5 times the temperature in degrees Celsius plus 32. Let's plug stuff in. 9/5 times temperature. Oh, we're actually plugging that one in. So 80.92 Celsius, degrees Celsius plus 32. All right, PEMDAS, parentheses, exponent, multiplication, division, addition, subtraction. We need to do the parentheses first. So 9 divided by 5. Let's go back to this one. Clear 9 divided by 5 times 80 point, I think it's 92, I believe. 92 is that. Plus, then we do the addition, 32. Let me do that in pieces. 145. So this is going to be 145.656 degrees Celsius plus 32. So temperature in degrees Fahrenheit is going to be 177.656 degrees Fahrenheit, but we need 4 sigfigs, so we're going to cut it off here and say 177.7 degrees Fahrenheit. All right, that was a long video. Sorry about that, but we need to put all of this into one. You can pause it, rewind it, whatever you need, but that's basically it. Well, thank you very much, and I will catch you next time. Remember, practice a lot. You can do it.